It says, draw and label the height of each parallelogram. Remember, we need to extend the floor, and then we need to measure what is the highest part of our parallelogram. So we're going to draw a line up to the top of our parallelogram from the floor, and we're going to call that the height. On this one, we have enough room here. We can just start from the inside and draw a line down to the floor and call this one the height as well. So that takes care of 1 and 2. Number 3 says to actually calculate the area of these parallelograms. So we have a parallelogram that looks something like this, and it's got a height of 6, a base of 13, and a slant of 8. Remember, the slant is there to confuse you. Cross it out, we don't want it. The area of a parallelogram is the base times the height. So in this one, our base is 13, and our height is 6. 13 times 6 is equal to 78. Area is a two-dimensional measurement, so we're going to call it centimeters, and we're going to put the 2 to represent that it's 2D, so centimeters squared. Number 4 is a very tall, narrow parallelogram. We've got 1.2 down here. We've got 12.8. And 13.4. The 13.4 is on a slant. It's there to confuse you. Again, area equals base times height. Remember, we can use that dot to represent multiplication as well. The base in this one is 1.2, and the height is 12.8. We can multiply by pretending the decimals are not there, and then we'll worry about them at the end. 2 times 8 is 16. Carry your 1. 2 times 2 is 4, but then add the 1, makes 5. And then 2 times 1 is 2. Now we need our place value spacer. 1 times 8 is 8. 1 times 2 is 2, and 1 times 1 is 1. And we add them up. 6, 5, and 8 is 13. Carry your 1. 2 and 2 is 4, plus 1 more is 5. Now we get to worry about our decimals. There's 1, 2 in our question, so we need 1, 2 in our answer. The area of this one is 15.36, and it was measured in feet. So it's feet squared. We've got 2.5 down here. 3 and 5/8 here. No, 5/6. Sorry. 5 1/4 here. And 7 2/3 over here. Let's get rid of the ones we don't want. This is on a slant. This is just part of the floor. It's not actually part of the base. Our area is going to be 2.5 times 5.25. A very common mistake that I see is students will multiply the whole numbers together and then multiply the fractions together. But that does not work. That's a really common mistake that people make. So let's try and avoid that. Instead, we want to change them to improper fractions. 2 times 2 is 4, plus 1 more is 5. So 5 over 2. 5 times 4 is 20, plus 1 more is 21. Now we can multiply straight across. Or we can look for things that divide out. 5 and 4 don't have any common factors, and 2 and 21 don't either. So it's not going to be a fun number to work with. But 5 times 21. I know 5 times 20 is 20, 40, 60, 80, 100. And then I have 5 extra. And 2 times 4 is 8. This is an okay answer. You do not need to change it back to a mixed number unless it tells you specifically. Don't do an extra step where you might make a mistake. This is mathematically the same. So leave it. And it was measured in inches, so inches squared. And last one, number 6. We have 4 1/3. Three and 5/6. And 3.5. We have to be careful about how we multiply our fractions here also. 4 times 3 is 12, plus 1 more is 13. 3 times 2 is 6, plus 1 more is 7. 13 times 7 is 91. And 3 times 2 is 6. It was measured in meters, so it's meters squared.